Namaste. This is JV and Dr. Vishal Saxena, Professor in Mathematics, JAYOTI Vidyapeeth Women's University, Jaipur. Today we are going to discuss on the module of multiplication theorem of probability, and this module of multiplication theorem is a part of the course numerical analysis and numerical methods under the program of BCA 6th semester of the university. In the today's lecture, we are going to discuss about this theorem, and this theorem is known as multiplication theorem. And as all we know that this is a very important part of the chapter, the subject probability and probability theory. And this theorem is very useful to solve the various numerical problems. And this multiplication theorem of probability gives the concept of conditional probability is also there. It includes the part of the probability of conditional probability. And in the today's lecture, we are going to discuss about this theorem with some numericals. And for this, we are taking some more slides to explain this more. First, we have to understand what is multiplication rule of probability. The multiplication rule is a very important part and which is just related with multiplication theorem of probability. And this multiplication rule of probability explains the condition between the two events. So this rule will just explain here the condition between the two events. And for the two events A and B, suppose associated with a sample space S, the set A intersection B denotes the events in which both event A and the event B will occur. So we are here discussing a sample space S, and the two events A and B are just associated with this sample space. And as already we know that A intersection B is called the intersection of two events A and B, and it includes the common part of the two events A and B. So therefore, this A intersection B, the event A intersection B denotes the simultaneous occurrence of the two events A and B. The event A intersection B can be written as also AB. The notation can also be given by AB, or it may be written as A intersection B. And the probability of event AB is obtained by the using the properties of the conditional probability. So it's a probability, means the probability of event A intersection B can be determined, can be explained with the use of the conditional probability concept. And now we are going to discuss about the multiplication theorem in probability. So we have already learned the multiplication rules we follow in the probability, such as P A intersection B. So the probability of A intersection B means the common part of two events A and B, the common occurrence of two events A and B, and its probability is given by PA into PB upon A, and PA intersection B can also be defined as PB into PA by B. These two results can be obtained by the concept of conditional probability PB by A and PA by B respectively. So the probability of PB by A is a conditional probability of event B when the event A is already occurred or is associated with event B, and it is a compulsory part of the event B to occur. So that is the conditional probability of event B upon A. So PB upon A, when we discuss about the probability of B upon A, event B by A, then this PB by A can be defined as PA intersection B upon PA, and in this way, the probability of PA intersection B can be given by PA into PB by A. Here, one important thing is that the probability of PA means PA must be not equal to 0. And in the similar way, the probability of A intersection B event can be defined as PB into PA by B. And again, this result can be obtained by the definition of probability of A by B, where PB is not equal to 0. And in this way, the multiplication theorems can be obtained for the two events A and B. P A intersection B can be defined for the two different ways here. And if A and B are the two independent events, so now this theorem can be just derived or can be defined for the two independent events of a random experiment, then the probability of simultaneous occurrence of the two independent events can be defined as the PA intersection B is equal to PA into PB. Here PA intersection B, again just this can be obtained from the above two statements about the first statement, suppose here. So PA intersection B is equal to PA and into PB, because PB is obtained from the PB by A, and the event, because both events A and B are independent, therefore PB by A can be can be written by only PB because the events are independent. So in this way, the multiplication theorem for the two independent events or two not independent events can be defined. And now we take just this. Now from the multiplication rule, we can see here the PA intersection B is equal to PA into PB by A. Just already we have seen. And because event A and B are independent, therefore already just we have discussed about that. PB by A is equal to PB, and therefore this PA intersection B, the probability of event A intersection B is given by PA into PB, because PAB by A becomes here PB, and therefore when we put the value of PB by A in the above equation, then it reduces to PA intersection B is equal to just PA into PB. So in this way, this is the probability of it is a probability of two events, simultaneous occurrence of two events, and this theorem is called the multiplication theorem in probability, and it is a very important theorem. Now we discuss this theorem with some example, and this will explain more here just how can we use this theorem for the various problems. So in this example, we see what is the statement there. An urn contains 20 red balls and the 10 blue balls. Now two balls are drawn from a bag, one after the other, without replacement. Means first one ball is drawn there from this bag, and after this, without replacing the first ball, the second ball is uh, withdrawn from this bag, from this urn, and the urn contains here 20 red balls while the 10 blue balls. So in this question, what is probability that both the balls drawn are red? So now we see there this how can we solve this question? So for this here, we have to make some statement there. Let A and B denote the events that first and the second ball drawn are the red balls. Because in this question, what is required here? What is the probability that both the balls drawn are red? So in this question, both balls should be red. Therefore, first we are defining here the event A as the first and the second ball drawn are the red balls in the event A and event B respectively. So in this way, we have to find P A intersection B, because the first ball which is coming red is the event A, the second ball which is coming red in the second drawn here in the second attempt, and therefore both balls should be red. Therefore, P A intersection B must be required there. And in this way, just how can we solve this question? Because PA, now PA means the probability of event A, means the probability in the first draw. First draw, the ball should be red, and its probability is 20 by 30 because there are 20 red balls and there are 30 total balls in that urn. So PA means the probability of drawing a first ball which is coming red is 20 by 30. But in the second attempt, when the second ball is drawn there, but the first ball is not replaced there. Therefore, now the urn contains 19 total balls, and the total balls are 19 there, and therefore the second ball should be red there. Therefore, because there are 20 red balls, and therefore if the second ball should come here red, then what will be its probability? So therefore, if first ball is gone red, it is already taken out from the urn. So therefore, 19 red balls are there, and total balls in the urn are 29. In this way, it shows the probability of PB by A. So 19 upon 29 is the probability of B by A event, and as a multiplication rule, it states that probability of A intersection B is equal to PA into PB by A. So PA intersection B is equal to PA into PB by A means it is coming there 20 by 30 and 19 by 29. Actually, just we can see it is 20 by 30 and 19 by 29 should be there, and therefore this becomes like here 38 by 87, and therefore this is the required probability of 38 by 87, and that is the required answer of this question. So in this way, just multiplication theorem can be used to solve the various problems of events. Just in the last question, we have seen there the two balls have been drawn. The first ball should be red, and when the second ball is drawn there, then the first ball is not replaced there. Therefore, in the second drawn, the the first event means the first drawn ball just affects the second event, and therefore the multiplication theorem is applied there. And according to multiplication theorem, we have seen there the probability of event A intersection B can be calculated. So this is a very important part of our course, and it is a very important part of probability. And we can we can take more questions on this concept to make clear our concepts. And now with this, I conclude my today's lecture. Thank you.